semiconductor manufacturing plays a pivotal role in the development of modern technologies. As electronic devices become smaller, faster, and more efficient, the need for advanced lithography technology becomes increasingly crucial. China, in its pursuit of technological advancement, has made significant breakthroughs in lithography technology for semiconductor manufacturing. This video explores China's achievements, the impact on the semiconductor industry, and the potential implications for global technology development. The significance of lithography in semiconductor manufacturing, 200 words. Lithography is a key process in semiconductor manufacturing that involves transferring intricate circuit patterns onto silicon wafers. It determines the density and complexity of integrated circuits, influencing the performance and functionality of electronic devices. Advancements in lithography technology directly impact the size, speed, and power efficiency of semiconductors. China's commitment to technological advancement, 200 words. China has prioritized technological advancement in its national agenda, recognizing the importance of semiconductors for economic growth and national security. The government has invested heavily in research and development, infrastructure, and talent acquisition to bolster its semiconductor industry. China's breakthrough in lithography technology, 400 words. China has made remarkable strides in developing its indigenous lithography technology. The country's significant breakthrough came with the development of extreme ultraviolet (EUV) lithography. EUV lithography utilizes a shorter wavelength of light, enabling the creation of smaller and more complex circuit patterns. This breakthrough has allowed China to reduce its reliance on imported lithography machines and gain greater control over its semiconductor supply chain. China has also made advancements in multiple electron beam (MEB) lithography, an alternative technique to EUV lithography. MEB lithography uses an array of electron beams to simultaneously pattern multiple chips on a wafer, significantly increasing production throughput and reducing costs. This technology is expected to play a vital role in mass production of next-generation semiconductors. Impact on the semiconductor industry, 300 words. China's breakthrough in lithography technology has far-reaching implications for the semiconductor industry. Firstly, it reduces China's dependence on foreign suppliers for critical lithography equipment, increasing self-sufficiency in semiconductor manufacturing. This newfound independence enhances national security and provides a competitive edge in the global semiconductor market. Secondly, China's advancements in lithography technology enable the production of cutting-edge semiconductors with higher transistor densities. This, in turn, boosts the performance and efficiency of electronic devices, supporting the development of emerging technologies such as artificial intelligence, 5G, and Internet of Things, IoT. Thirdly, China's progress in lithography technology challenges the dominance of traditional semiconductor manufacturing powerhouses, such as the United States, South Korea, and Taiwan. It disrupts the established supply chains and compels other countries to adapt and innovate to maintain their competitive edge. Potential implications for global technology development, 400 words. China's breakthrough in lithography technology has the potential to reshape the global technology landscape. By reducing reliance on foreign suppliers, China aims to establish itself as a major player in the semiconductor industry. This could lead to shifts in global trade dynamics and geopolitical influence. Furthermore, China's advancements may drive increased collaboration and competition in the semiconductor industry. Rival countries and companies will seek to develop their own breakthroughs or form strategic partnerships to stay competitive. This intensified competition could fuel rapid technological progress, benefiting global technology development as a whole. However, it is important to note that China's rise in lithography technology is not without challenges. Intellectual property concerns, technological barriers, and the need for sustained investment pose hurdles that must be overcome. Collaboration and knowledge sharing between countries will be essential to addressing these challenges and fostering a healthy and innovative global ecosystem. China's breakthrough in lithography technology also has implications for intellectual property rights. As the country develops its own advanced lithography solutions, concerns have been raised regarding the protection of intellectual property and the potential for unauthorized use or replication of patented technologies. Addressing these concerns will be crucial to fostering an environment of fair competition and encouraging global collaboration. Furthermore, the advancements made by China in lithography technology can potentially stimulate the development of related industries. The demand for specialized materials, equipment, and expertise in lithography will create opportunities for suppliers and manufacturers. This could lead to the emergence of new companies and the growth of ancillary industries, thereby contributing to job creation and economic growth. China's breakthroughs in lithography technology are not limited to domestic applications. As the country strengthens its capabilities, it may become a prominent player in the global semiconductor supply chain. Chinese companies could expand their presence in the international market, offering advanced lithography solutions to semiconductor manufacturers worldwide. This could lead to a more diversified and competitive market landscape, offering customers a wider range of options and potentially driving down costs. However, it is important to note that the development and adoption of advanced lithography technology is a complex process that requires significant investments in research, development, and infrastructure. China's progress in this field is the result of years of strategic planning, investment, and collaboration with international partners. It serves as a testament to the country's commitment to technological innovation. China's technological challenges and future outlook, 400 words. While China has achieved significant milestones in lithography technology, it still faces several challenges that need to be addressed for sustained growth and global competitiveness. One major hurdle is the development of next-generation lithography technologies beyond EUV and MEB. The semiconductor industry is constantly pushing the boundaries of miniaturization, and China will need to invest in research and development to keep pace with evolving industry requirements. Another challenge is the acquisition and retention of talent. Building a skilled workforce capable of driving innovation in lithography technology is essential. China recognizes this need and has been investing in education and talent development programs to cultivate a pool of skilled engineers and researchers. Additionally, intellectual property protection remains a significant concern. China's progress in lithography technology has led to scrutiny regarding potential intellectual property infringements. To foster a healthy global technology ecosystem, China must ensure the protection of intellectual property rights and adhere to international standards and regulations. Despite these challenges, China's future outlook in lithography technology remains promising. The country has demonstrated its commitment to innovation and technological advancement through strategic investments and collaborations. China's semiconductor industry has gained momentum and continues to attract top-tier talent, both from within the country and abroad. Furthermore, the Chinese government's supportive policies and financial incentives have created a conducive environment for research and development in the semiconductor sector. This favorable ecosystem, coupled with China's growing domestic market and its increasing role in the global supply chain, positions the country for further advancements in lithography technology. The global implications and response, 400 words. China's breakthrough in lithography technology has sent ripples throughout the global semiconductor industry, prompting other countries and companies to reassess their strategies and invest in research and development to maintain their competitive edge. Traditional semiconductor manufacturing powerhouses, such as the United States, South Korea, and Taiwan, are intensifying their efforts to stay ahead. These countries are investing in cutting-edge lithography technologies, exploring alternative approaches, and forming strategic partnerships with industry leaders to accelerate innovation and secure their positions in the global market. Collaboration is becoming increasingly important in the semiconductor industry. The complexity and cost of developing advanced lithography solutions require partnerships between equipment manufacturers, material suppliers, and semiconductor companies. Cross-border collaborations and knowledge sharing will foster technological advancements and benefit the industry as a whole. Moreover, China's advancements in lithography technology have spurred a global conversation on the need for diversification and resilience in the semiconductor supply chain. The industry's heavy reliance on a few key players for critical components has been exposed,